Rightio, and welcome back to the second part of this series on Azure Machine Learning. Hopefully you guys can notice there is an improvement on the audio quality as I've invested in a new mic. And if you're enjoying the content, make sure you subscribe and smash that thumbs up button, as it does go a long way to help the channel. So first things first, I want to correct a few things in the pipeline which I've noticed. So if we go to the clean missing data and we look at the columns, so yep, age is one of the columns that we want to remove, but you'll notice that it is lowercase here, but in fact in the data set it is, the A is uppercase, so that has to be replaced there. And on our train model, we need to do the same for survived. So just survived there. And that should now be us good to go and train the model. One other thing I'm going to have a look at is the missing data. So if I just go to data sets, Titanic, train, explore, and profile. So previously we just checked the missing count column and we noticed that age was missing some values, but what I forgot to check was the empty count column. And you can see there's some missing data in there as well. So what I'm going to do is go without these two columns at the minute, just for the purpose of this demonstration. So we'll go back to the designer, go back to our pipeline, select columns in the data set, and we want to remove cabin, and I think that is it. Yeah, we can see embarked has not been picked previously. Okay, so I think we're now ready to run the ML pipeline. So in order to do this, we need to set up two things. We need to have a compute cluster and we need to ensure that an experiment has been set up. So I will just save this here, go to the settings icon and select a compute target. So we'll go create new and give this a compute target name. So I'll just call this train cluster ML. We can hit save and that will now create that new compute target. Okay, so if we now navigate to compute and we go to training clusters, we can see this is being provisioned. So let's wait until this has been completed before we go on with the next step. Good news, our training cluster has been successfully provisioned. So let's go back to designer, back to our pipeline that we created, and we can now submit this. So if we go to submit, we will create a new experiment. So Titanic train XB, and we can hit submit. So this takes a little while to run, so I'll let this finish and I'll check back in once it's completed. But that is essentially it. We have created our ML pipeline and we have submitted it to the training cluster for it to be trained. So once that's finished, I'll check back in with you guys. Okay, welcome back. Through the magic of video editing, it should only appear that took 2 seconds, but yeah, that actually took a good few minutes, so don't worry about that. So we'll just go and see how well our model actually done. We're not expecting anything great because there was little data pre-processing done. So we can go and have a look at evaluate. And outputs and logs. Visualize. Okay, so we've got a few different evaluation mechanisms here, but we can see the overall accuracy was around 0.86, so about 86%. The model predicted correctly on this test data. So that's fine for the minute. Let's just go ahead and actually publish this pipeline. So we'll just close this. So we want to create a new inference pipeline in real time. So just submit that. What this does is it creates essentially a copy of this pipeline. It adds in 2 new modules. We've got web service input and web service output. It removes the train split and train modules as well. So let's submit this again. We can use our existing experiment and just hit submit. And again, this will take a few moments to run, especially if the cluster has not been set up and the nodes aren't attached to that cluster. So I will check back in with you when this is complete. The pipeline has been completed, so it's now time to set up the Kubernetes cluster which the model will sit on. So what essentially happens is the model is deployed behind a REST API, and that is hosted on a Kubernetes service. So if we go to compute, go to inference clusters, and we create a new one. So Titanic AKS, we will go to West Europe, and the virtual machine I'm going to go for is an A2V2, and we will use the dev test cluster purpose and hit create. So that will start to provision that Kubernetes service. It's important to have a look through the VMs and the specifications of them to understand what VMs that you want to use for your model deployment. And there's also usage and quota rules specified in the portal, so it's worth checking them out as well. Once this is complete, I'll check back in with you guys. Kubernetes cluster has been provisioned successfully, so we can go back to designer, go back to our inference pipeline, so make sure you're on this tab here, and we can hit deploy. So what we want to do is deploy a new real-time endpoint. We can rename this Titanic endpoint. So that is the Kubernetes cluster we just provisioned there, and we can hit deploy. So again, that will go ahead and take a few minutes to run, so I'll check back in with you guys once that's completed. So our model has been deployed to the Kubernetes service, so we can go and check this endpoint out now. Endpoint, so this is the endpoint we just created, Titanic endpoint. That will just load up, and we can now test our model. So it's pre-populated some data for us. We can just hit test. So we can see that this is the data that has been supplied to the model. So we have the gender, which class, the age, sibling or spouses that this passenger may have had, the fare that they paid for the ticket, and it's scored as 0, so it's predicted that this passenger has likely to have died. So that brings me to the end of this tutorial. Be sure to subscribe and give this video a thumbs up if you enjoyed the content. In the next video, I will be looking at how we can further improve our model using some of the modules that's in the Azure Designer and perhaps some data pre-processing.